So around 6 of you, the 6 of you here. I know which class you guys from. 华语可以还是英文可以 ？Both can, huh? How about the rest? Can. Okay, sure. So which class you guys come from? Huh? 2409. 2409. Last year. So you are in calculus 2 now. Okay. So it's the current same. And then same. Okay. So you guys are Malaysian or Chinese? Chinese, two Chinese. Malaysian. Okay. All right. I think you should have a handout. I'm not sure Raisha is sending out or not. Basically, today they asked me to discuss about limit. Is this what you learned in class? Yeah. Okay. So maybe we'll start with that definition then. Can you see or not? Should we turn off the light? Can see? Okay. So any one of you want to remind what's the limit definition is? So what thing has a limit? Fx. Okay, so a function. Okay. So let's say a function. Seems like this table have some in it. Okay, the function f, right, has a limit, let's say p at x if absolute value of f equal to p like this, and then greater than epsilon. No greater than epsilon. Yeah. Anything else you need to put here? Huh? Anything else you want to put here? Absolute value of x minus something else. What's that? Okay, in that case, let me change this point here at y. X minus y. And then in between 0 and delta, good. Okay. And then how to put it together? Every epsilon, then with the delta. Both of them greater than 0. Okay. Such that if x minus y is in between 0 and delta, why is that? Not quite complete yet, right? F minus p here. What do you need to put here? P is a point. You need to understand where this P, where do you choose this P? So to understand this, right, you need to understand the function first. Functions, what does function do? What does function do? Fx, right? What's the x doing there? Transforming. Okay, very good idea on the function. Some transformation are called function. So function do what? You give an input, it give you an output. Okay, so it has a domain and codomain. Okay, so you have a domain space and a codomain space. So the function you study, right, usually is from R to R. Meaning what? You give a real number to this function give you a real number. Okay. So what is this P and this Y? Where's this P and this Y? Huh? What are these P and this Y here? Live in where? Are you guys familiar with this notation here? R here, real numbers. Okay. So this P and this Y should also live in real numbers. Okay. Well, these two real numbers is a bit different. It's a bit different. Okay. So where the function takes point in, right, we call it a domain. And when it's split out, we call it a codomain. Okay. So if I say that a function f has a limit p at y, this y come from which domain or codomain? Domain. Okay. This point here actually live in the domain. Okay or not? Okay. So if you know something about domain x minus y, you should know something about the codomain. Okay, in particular the image. We said the image of f, okay, where the f can match to. Okay, so we should put a fx here. Okay or not? So the fx is a real number. P is also a real number. Only then you can subtract real number. Does it make sense? Does it make sense or not? Fx is a real number. P is also a real number. So you can subtract real number. Correct? Okay. But what is epsilon and delta means, right? Where are they living? What value you can take for epsilon delta? Can you take complex number? No. Okay, so here epsilon and delta also some real number, positive real numbers. Okay. 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 So let's put this for every epsilon. I'll put that if so x minus y is going to be delta, then we get hey, is the handout given out yet? Have you guys got the handout? Teams. You guys can open up your Teams. Where to find it? Yeah, try and open up that thing. We might able to go through all of them. Either we don't, either we go through all of them. Depends. But most importantly is you should understand this definition by tonight. Okay. So some of you have taken discrete math, some of you haven't taken discrete math. Okay. So in discrete math, right, one very important subject in the first order logic is quantifier. Okay. Do you guys recognize this symbol here? Recognize it? Can you tell me? What are they? So for the first one, this is an inverted A. What is this? For all good. Okay, so how do you remember this? For all has an A, right? Okay, so they just invert the capital A here. Okay, because in those old days, right, they only have typewriters. So how do you produce a new symbol? You just lift the keyboard out and then invert the thing. Okay. How about the inverted E? The axis. Okay, so axis E stem from the axis. And if you come for the epsilon delta, right, maybe you can sit closer. So that we got some interaction here. 可以听懂英文吗？听得懂吗？听得懂哦。可以近一点呀 ，OK 吧？近一点不然听不到看不到。还好哈，OK OK。我怕我听不到你，所以你可能要大声一点。OK OK。So this one there is this. Yeah, 这边真的是不好。Okay, so how do you imagine this definition here? Yeah, so there are two ways to see. So this line here is called statement. In mathematics. In mathematics, usually we just deal with statement. What can a statement do? What can a statement do? Huh? What can a statement do? You can decide. You can decide a true value for your statement. So what are a true value given to a statement? True or false? Okay, in mathematics, there's only two possibilities. If I gave you a statement, it's either true or false. Okay, similar for this statement here, either it's true, either it's false. Okay, so given a statement to you, either you want to prove it, either you want to use it. Okay, so there are two ways to read this statement here. Okay, let me. Okay, so there are two ways to see it. One is proving it. One is assuming it. Do you know what's the difference between these two? Proving and assuming? No, proving is you don't know whether it's correct or not. I want to prove it. I want to prove it to you. It's correct. Assuming it, assume is correct. Don't need to prove anymore. Okay. So if you want to prove the statement with quantifier, in particular, there are two quantifiers here. Okay, for all that exists. How do you prove it? How do you prove a statement that have a universal quantifier at the front for all x? For example, I give you an example. Prove that every tomato is red. How to prove? 讲证明，讲证 how to prove？每颗西红柿都是红的。哎，不要跟我讲西红柿里面有红，它就是红的。How to prove? Every tomato is red. Well done. Yeah? False. No, I want to say how to prove it is true first. If it is true, how to prove it? If you want it to be true, what should you prove to me? How do you prove to me? For all statements, how do you prove? I give you a very real life example. Okay, maybe you tell your friend, hey, today's Kota Warisan has a sale. What banana is very cheap. Very cheap. How cheap? How cheap? Below three. Below three. Okay, I go to the Keep Mall I buy 香蕉你讲3块钱以下，不是中午看到是4块钱。I found one banana is more than 3. Then this is a counter example. Okay, no. So what do you mean? You want to prove every tomato is red? Simply grab a tomato, and then you need to show that it is red. Simply grab. Understand? Okay. So in this case, I want to prove that this statement is true. What do you need to do first? You need to start with any epsilon greater than 0. Okay. And then there exists a delta. So it means what? We need to find a delta. Okay, and we need to find a delta. Potentially, this delta is depending on epsilon. That's fine. 可能会跟着你的 epsilon 变的，不用紧。But for every epsilon, you must find a delta. But this delta is not random delta. 不能跟我讲我要找一辆车，随便找你一辆车嘛，对不对？我要找一辆可以坐7个人的车呢。I don't know. What does this delta have to satisfy? Can you read from the statement? What does this delta have to satisfy? What does this delta have to satisfy? So here now come to this part here, the second part here, the thing after such that. Okay, so basically you can split this sentence into three parts. Okay, after each quantifier, you make it one part, and then this last part here. Anyone understand what's this last part here from your discrete math? What is this? Something arrow something. No, this is not an if and only if because there's only one direction. If and only if means two direction. Here only got one direction. Sorry? Implies, yeah. So what implies what? So that thing implies that thing, which thing? Okay, so the left statement here will implies the right statement here. You know? Okay. So if P is true, okay, so let's call this part here P. If P is true, then Q is true. You know? Okay. So meaning what? You need to assume P first. Okay, you need to assume P first, and then you want to prove that Q is true. Okay. So if you take an arbitrary epsilon here, find a delta such that if you have an x minus y is in between 0 and delta, want to show that the absolute value of fx minus p is reading epsilon. Okay. So in the end, what you need to check is the q here. You need to check the q. Okay, p is given already. Okay, p is given. So well, I think there's a bug here. There's a bug here. Y is fixed. Okay, so you see so this point y here is fixed, and p here is fixed. What's not fixed is x. So you also need a quantifier for it actually. Okay, what's the quantifier you need there? Actually is for all x. Okay, for all x. For all x that fall into this range here, then you need to prove that the last q there. Does it make sense? Okay. Okay. So this is proving. How about assuming? If you want to assume the whole line here, how do you use it? Something that's true for all. Let's say I say, already proven that every tomato is red. Already proven. So if I grab any tomato, it is red. Okay, so if it is true for all epsilon, meaning what? If I I choose epsilon greater than 0, then we can find and delta greater than 0, okay, such that if P holds, then we have Q holds. Okay. Okay. So in this statement here, most important thing is the Q there, the last bit there. Okay. But to make the last bit happen, what do you need? You need epsilon first. Okay. Once you have the epsilon, this statement will give you a delta. It's such that if P holds, and then Q will work. Okay, so this is just a logic part. So this is just a logic part. But what it really means, what do you think? What it really means? 什么意思啊? So what does it really mean here? Do you have a picture in your mind? Do you have a picture in your mind? What picture do you have? Should you have? I mean, this picture should inherit from your high school. So this function, right, is a function from R to R. Okay, so domain is R. Codomain is also R. Okay, usually you name them as x-axis and y-axis. Okay, So imagine you got a function like this. Okay. And just now we need a p, right? I need a y and a p. Do we call it y? Yeah, we call it y, right? So let's pick a random y here. Okay. But this function will take values at this y. What's this value here? Anyone know? Fy. Good. So this point is Fy. Okay, so basically, you can make this dotted line here. Fy. Okay. So, from your intuition, from your understanding, from your everything, anything, do you think this function has a limit at y or not? How do you see it? Can you tell us? Continuous, wow. There's another concept coming in here. Okay, how about the rest? What do you think? Do you think it has a limit here? Huh? Do you think it has a limit here or not? How do you see limit? So typically you will want to approach this y, right? So there are a few ways to approach this y. You can go from there or you go from right. There are more than this way, 不一定要从左从右啊，你知道吗？我可以跳 I can jump around as long as I get closer to this way. OK, approach 嘛，对不对？不一定要这样子靠近它了吗？我可以降一下，再降一下，再降一下，再降一下，还是再靠近它嘛，对不对？对 ，OK. So, well, if you notice, if I move around y, I also can study the value of x around y. 对吗？ Let me draw. So you move around here, right? You also can study all the value here. What can you observe here? If you move around y, what happened to this f value here? Also get closer to f1. Okay, so let's call it p. Just now we say this point has a limit. Let's call this point p. Okay. So what does this epsilon delta capture here? So let's write down again. So you need to, if you don't understand, you need to first memorize like a chant. You know what's a chant? 咒语这样，念嘛一直念，回家念，大便念，冲凉念，吃饭念，睡觉念，睡前也念一遍，醒来再念一遍，念到你能够记忆起来为止。Okay, for every epsilon greater than 0, there exists a delta greater than 0. This delta could be dependent on epsilon such that if x minus y is in between 0 and delta, then fx minus p will be less than epsilon. Okay. So you see, I'm a result-driven person. So I directly see the statement P, statement Q first. Okay, what's the result here? Fx minus P less than epsilon. What does this mean? Anyone know what's the definition of absolute value is? What's the absolute value means? Absolute value definition. What's the definition here? Try. 错不用紧啊，我们学吧。Distance. Okay, yeah, sure, it's a distance. So can you define for me this function here? How does this give a distance here? What sort of distance giving here? X is bigger than 0, and then negative f is if x is less than 0 equals 0. So which case you can take? Both can. Okay, put it into one of them. Both of them also can, because negative 0 and 0. How is it the distance for? How is the distance? What is the distance? 又有 s 又有减 s. Your distance can be negative. Huh? What is the distance? Distance from where? Distance must have 2 points, right? X is just 1 point. Where's the other point? 0. Okay, so you're actually counting how far this X is from 0. Okay, for example, 2 and minus 2 is the same distance from 0, which is 2. Correct? No? Okay, so the minus X there is really catered for the negative number there. Okay, so in this case here, so if you want to bound this, you need to bound this absolute values here. What does it mean? If your absolute value is less than some number, what does this mean? This means that fx minus p is bounded with epsilon and minus epsilon. What does this mean? You can play further algebra here. Right? This means what? Fx is actually in between p plus epsilon and p minus epsilon. But do you know what is p plus epsilon and p minus epsilon now? I tell you what is p already. Epsilon is just some positive number. So where is p plus epsilon? So on the number line, p plus epsilon higher or lower? Higher, right? So maybe somewhere here, such that this distance is epsilon. Minus it, go below. Okay, so it's really symmetric around. P. Okay, so actually it's talking about this area here. P plus epsilon and P minus. So what else? Okay, we already see our goal already. So our fx have to lie in between this line here. Okay, our fx have to lie in between this line here. Let me draw this graph a bit. Let's draw it a bit longer. And then let's do some trick here. So let's do a little trick here. So let's move this graph a bit lower. Okay. Okay. Okay, let's change our f to this. Right. Okay, since I tell you this part, right? Can anyone tell me what's this part here, the p part here, to refer to? What's this p part here? Anyone open up this absolute value for me? Anyone open it up? Huh? X minus y lesser than delta. Okay. Negative greater than negative delta. But how about the greater than 0 part? Sorry. Greater than 0 means what? The difference between these two cannot be 0. But if you write it as x minus y in between delta and minus delta, do you have 0 there or not? Correct. So you need to add an extra condition. What's the extra condition here? What's the extra condition here? How do you exclude 0 here? X cannot be equal to y. X cannot be equal to y means what? Cannot be the same point. Okay, so meaning what? We don't really care about the x at exactly y actually. We don't care about it. We don't really care about it. Okay. Even if at this point, like what's your name? 讲一下。OK, interesting。第二名字忘记掉。Michael Jackson 啊，哎，不要这样谦虚啦，讲一下你的大名，让人家认识一下你。哎，不要这样，不给脸呢。啊啊，优先哈，OK，优先，yeah。So Yushan, later ask them to give you a prize, most active prize. Okay. Yushan, okay, 我记得你了。Okay, so meaning what? Even if I define this point, not on P, there will also be a limit here. Okay, as long as the nearby point have closer value to P. It doesn't matter what this Fy take. We could make this Fy far, far away also. Okay, but you say that this graph is not continuous, right? Because there's a hole here. But continuity is the next issue. But now we just care about limit. Okay, if we just talk about limit here, we don't really care about the point on y actually. The value taken on y. We don't care. We just want the nearby point to get closer to some value. Okay, no? Okay, so how do we check this? How do we check nearby point? Get closer to this value. Obviously, you want to shrink the epsilon. Okay, if you make the epsilon smaller, is it still closer to this point or not? Make it smaller. Is it still closer to this point or not? Closer means what? There must have some x that realize this value here. Okay or not? Okay, I give you an example that doesn't have a limit. So I think this is a very classic example you see in class. So let me go back here. So if I make this function here like this, okay, let's say we discuss about this point here, this middle point here. Let's say here is 1, here is 3, and then this middle point here is actually 2. And this middle point here is actually 2. Okay, so is it still true that for every epsilon greater than 0, there exists a delta greater than 0, such that if let's say this point is called 1, such that if x minus y is less than delta, then fx minus 2 less than epsilon 1. Is it still true or not? This statement here. If it's true, when is it true? If it's false, when is it false? Okay, tell me when epsilon, what kind of epsilon you take, it is true. And what kind of epsilon you take is false. So for every epsilon, right, you need to check for every epsilon. What kind of epsilon you can pick? Like give an example. 来这位，什么 epsilon 你可以选？什么？选一个啊，不要好死不死就给我一个 negative 的。positive 的，我这边写 positive，选一个 positive 的啊，二分之一，二分之一哈，OK，二分之一，有没有人要不要选大一点的？要不要选大一点的？啊？two 啊，OK OK，未来。So we got a two choice here. One is epsilon equals to half, the other is okay. So if you do epsilon equals 2, what do you get here? So 2 plus 2 is 4. And so if we have epsilon 2 here, this is your so here is epsilon 2 negative of epsilon 2 minus this, and the other is epsilon 1. Okay, so sorry, epsilon 2 first. Let's look at epsilon 2 first. If you look at epsilon 2, can you find a delta such that if your x is in between this delta range here, so how should I draw this delta? So this part we call delta A. Okay, which delta you should pick? You can pick such that your fx live inside this region here. Okay, what delta you can pick here? How far you can pick such that the fx values lie inside this green box here. Infinity. Yeah. Okay, if can you pick infinity or not? Delta is elements in where? In R, huh? R got infinity or not? No. Okay. Infinity is not enough. Okay, so pictorially, any delta you can pick here. Okay, any delta. Okay. Any delta will work. But if you shrink this delta, let's say you pick delta 1 now. So it's what? Half. Okay, so let's say it's here. And so here is minus delta 1 along with delta 2, delta 1, sorry. Okay. Any delta works or not? Can you pick any delta such that your fx lie in between this range or not? Can or not? Can you find any other fx inside this range? You can see that your fx will lie outside the range. Yeah, no? There's no delta you can pick. Okay, such that fx lie inside this range here. But if you want to talk about limit, it has to be true for all epsilon. Okay. Okay. Can you see that? If I pick this epsilon here, let's say this epsilon here, where's the delta I can pick? Can I pick this delta or not? So here, one plus delta. Can we pick this delta here? Can or not? Can I pick this delta? When you consider positive delta, right, y plus delta, the other side you need to consider y minus delta. Okay, so how big is y minus delta? So it should be symmetric, right? So around here. So let's say around here. Can I pick this as my delta or not? What do you need to check? Still remember what do you need to check? The Q, the condition Q. Fx minus P have to be less than epsilon. Meaning what? You need to fall into the range of this pink box here. Does it fall into this range or not for all the effects inside this delta here? Huh? The claim is no. Why no? No meaning someone lie outside this box here. What point lie outside this box here? There's some point doesn't satisfy fx minus p less than delta, although it satisfies x minus y less than delta. There's some point doesn't satisfy fx minus p less than epsilon. 1 minus epsilon. Y minus, oh yeah, right, correct. You are right. Okay, actually this point itself is not lie inside the epsilon range here, delta range, epsilon range. But we doesn't really care about that point, We are not taking y minus x equals to y minus delta, strictly less than. But you can see that all these points, right, lie outside the epsilon range here. Correct? Okay, so let's call these this box here as epsilon range of p. Okay, so this point here. Okay, epsilon range of p. Lie outside, right, this part here. Okay, but these x lie inside the delta range of 1. Okay, okay, so let's give them some name to easy easy recall them. So let's say this is the epsilon range, and this part is the delta range. Okay, every x inside this delta range here, their fx must be in the epsilon range of. Make sense? Make sense? Okay 吗 ？Any question？ 有问题吗？这个不是补习班啊 ，OK， 这是讨论班 ，OK， 所以不是就我在讲话了。Not tuition no tuition in university, OK. You must discuss your knowledge. Any question? 有问题吗？ Feel free to ask, okay? And then be brave to make mistake. Okay, when you make mistake only, then you will know what to do. What's the right thing to do? Okay, if you do the right thing 100 times, you fail one time, then you never get out anymore. You understand what I say? Okay, yeah. Is it clear? Okay, clear. So we can try question, is it? Okay, let's try question. Let's try some question here. Okay. So let's prove this first example here. All right, so let's do the first question. So that limit of x to 2 of 3x plus 1 equals to 7. Okay, so if you read in word, what does it mean? When your x go closer to 2, what's your fx here? In this case, can you read out your fx? Huh? What's your fx? What's your function? 3x plus 1. Okay, so consider f to be a function from real number to real number that send x to 3x plus 1. Or sometimes you will write it as fx equals to 3x plus 1. Right? So now I'm telling you a more advanced way to write this function. Right? This will be very useful for later year course. So it tells you very clear that this function is coming from what space to what space. Okay, and then tell you that how I send an element in the domain to the codomain. Okay, sending x to 3x plus 1 here. So when your x get closer to 2, you look at the fx, how the fx change. How the fx change, it also get closer to 7. Okay. Well, I mean, for this kind of max, right, you can draw the geometry, you can sketch the graph. You know how to sketch the graph of 3x plus 1 here? How to sketch? Find 2 points. Okay, how to find 2 points? When s is 0, okay, so when s is 0, what's the fx here? Okay, so f0 I'll give you 1. So you have 0, 1 point here. And then? What's the other point you want? Y is 4. Y is 4. You mean set y is 4 and then solve for x? Wow. Why you think of 4? Can you tell people? 4 then the coefficient of x. Obviously, you get 1. Okay, in the other words, if you substitute x equals to 1, you get 4. Right. You just make a clever substitution. You could make -1 also, depends. Right. He made 1. So f1 is 4. When 4 is 1, here is 4. Okay, it's 1. Okay, let's pull this up a bit. All right, then what do you want to do with these 2 points here? How to link? Can I link like this? Straight line only? Yeah. Oh, so strict one. Only straight line. Oh, cannot link. You said link only. I can link anywhere I like. Why is it linear? Because it's linear. Very good answer. Because it's linear. What does this linear function has? What's the property that linear function has? Yes, the gradient. The gradient is a constant. In this case here, what's the gradient? 3. Okay. Hopefully you have remember from your high school. Okay. So because the gradient is constant, so you have this linear right here. Right. So the question about would ask about s to 2. Where's 2 here? Where's the point 2? X equals to 2. Where is it? On the right hand side of 1. Yeah, on the right hand side of 1. Can you try and evaluate your function at this point or not? Before looking at the limit. If you want to try and evaluate, can you evaluate it? This function? Does this function take values at 2 or not? What do you get? Also, 7 is wow. So meaning what? The limit is the same as the value you take at and take under this function here. Okay, you also get 7. Okay. So can you try imagine the epsilon business that we talked about just now? If you fix any epsilon, can you find a delta region such that all the fx live inside here? Can. Why are you so sure? You are sure. Oh, intuition. Wow. Okay. Good. You are good. You are very good. You know, when I tell my student, you should use your intuition. You know what my students say? Sir, what is intuition? Yeah. What is intuition? Okay, so better you build a good intuition. Okay, it's good that you build a good intuition so that it can help you to go further in maths. Right. So what kind of intuition you had here? I think you have an intuition of continuity, right? Okay, meaning that points joins together. I mean, in the level that you would. I mean, is it what you know about intuition or not? Points can join. What's in your mind about continuous? Oh, you did this problem before. Okay, good. I mean, I'm asking about continuity. Does anyone of you know about continuity or not? Just now you mentioned about it, right? Wow. Where did you learn it? Wow. What's your high school? UEC. Oh, you learn in UEC. I see. Chinese or English? Oh, in Chinese. Where are you from? Johor. Hanro. Okay. Which part? Which school? Huh? Huang. Ah. Jingsen, huh? You got a senior, you can know about it. Yeah. Okay, right. So we're gonna use epsilon delta to prove here. So what's the epsilon delta statement here? Can anyone repeat for me? What's the chant? What's the mantra here? What's the mantra? For every epsilon greater than 0, there exists a delta also greater than 0 such that if x minus, in this case, what's your y here? Okay, yeah, good. If this x minus 2 is less than delta less than 0, this will imply that fx minus 7, good, is less than epsilon. Right. So what do you do here? You want to show, right? You want to prove this universal statement. You want to show that every tomato is red. So you just pick a random tomato. Okay, so just start with, how do you start? Take an arbitrary epsilon. Okay. Read until here. Some students we'll just go and find delta. Just go and find. I don't know how to find one. 老师怎样找 delta？ 怎样找？怎样找啊？没有条件的你要找哦，当然要有条件啊。比如讲你要女朋友，我不可能随便选的嘛，对不对？对不对？如果你讲你要戴眼镜啊，我找个没有戴眼镜啊，你不是不要，对吗？So what's the condition that you need to satisfy to find this delta here? What's the condition you need to satisfy? What's the end goal? What's the end goal? Okay, improving, you need to ask about your end goal, you know. Where's your destination? 你的目的地是什么？你目标是什么？ What's your end goal? What does it need to satisfy? Get what? What thing? So many things here. Which thing? Spell it out. So your end goal is absolute value of fx minus 7 less than epsilon. Okay? But what is fx here? What is fx here? Yeah, good. 3x plus 1. So you want to make sure that this is less than epsilon. But if this is less than epsilon, meaning what? 3x minus 6 is less than epsilon. I just simplified. I did nothing special here. Okay? Well, you need this to be true. But what's your assumption you can take? The assumption you can take. So here is the goal. Here is your goal here. Okay, what's the assumption you can take? You can control your x minus 2 less than some delta. Okay, but this delta you need to pick. You need to choose one. Okay, I'm not sure what to choose yet. But I need to reach the goal. So one is your assumption, one is your goal. How far is x minus 2 to 3x minus 6? 3 times. Oh. Okay, good. You see this pattern here. So, well, you can make this into 3 times x minus 2 first. Okay. So what did you see here? What did you see here? We are getting closer to x minus 2 already. What should we do next? We are now working backward. Try to work backward. What do you do next? We already want to do that. Okay, so what value you want to take? Okay, so what delta you want to pick? What are you gonna pick? Yeah. Any other suggestion? Delta less than epsilon. Pick delta less than epsilon over 3. That is. Pick delta less than epsilon over 3. Can I just pick equal to epsilon over 3 or not? Also can. Okay, do you know what it means by picking delta as epsilon over 3? Epsilon is a number, do you know? It's a fixed number, you know. I already fixed epsilon at the first place. So what this epsilon could be? Like just now you guys suggest, right? Half, 2, 100. So meaning what? This delta could change. If it's 100, then it's 100 over 3. If it's 2, it's 2 over 3. This delta. Okay, so this delta depend on epsilon. So sometimes we write like this. Delta depend on epsilon. Okay. And then how it works, if I do this, then this delta here will become epsilon over 3. And but this is true if only if 3 times absolute value of x minus 2 is less than epsilon. Then am I allowed to put the 3 into the absolute value or not? Can I put it in? Can No, not sure. Don't know. Can Why? Oh, 3 is positive. Okay. So actually here, There's a property you need to use here. So 3 times absolute value of some y should be equals to the absolute value of 3 times. Okay, do you know this 啊？有人知道这个吗？啊，人知道吗？ I mean, in calculus one, we won't prove this. If you go to MA1, maybe you need to prove this. Okay. Yeah. Huh? Oh, discrete math already prove it. You guys prove it in discrete math? Did you guys do in discrete math? Not sure. I said got in the chapter function, in the function chapter. Yeah, I'm not sure. But I make my MA1 prove this. Yeah. Okay. But anyone have issue with that property or not? You can put the scalar in. 有人有问题吗？有异议吗？ Well, I mean, you can write down both sides, right? Just now I already tell you the definition, right? What's the definition, huh? What's the definition of both sides here? So on one side is 3 times y, if y is greater than 0, and 3 times minus y if y is less than or equal to 0. But on the other side, absolute value of 3y. It is equal to 3y. Oh, the other side. Maybe just do a quick proof here. So this is one side. The other side, what did you see? You get 3y if 3y is greater than 0, negative 3y if 3y is less than or equal to 0. But if 3y is greater than 0, it is equivalent to y greater than 0. If 3y is less than or equal to 0, it is equivalent to y is less than or equal to 0. Okay, so actually they are the same function. Okay, they are the same function. Okay or not? Does it make sense? Understand? What am I doing here? Understand? 有问题吗？有问题吗？ Tonight, you come here to ask questions. Make sure you ask a lot of questions. Okay, otherwise, you go back to class, you still blur, still confused. Any question on this too? Okay. 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 So all these lines will follow, and then you will get your goal here. Okay. So you have proven. So for every epsilon, you choose this delta here, and then make sure that if your delta, your x lie in the delta range of 2, you make sure that your fx lie in the epsilon range of between 1 7. Understand? Okay. So what's the principle I teach you here? Result driven, target driven. Okay, you need to have your target first. You know what's the end goal you want to reach. Okay. What time is it? Should we take a break or not? Should we take a break? Very sure. Do we need to take a break? Huh? Let's take a break. Huh? What? You want to continue? You guys want to break or you want to continue? I think you should ask about the stakeholder. You guys want to take a break? Okay, let's take a 10-minute break. Until 8:52.
还不一样，那放在一般。那现在你找一个长度吧。我先不会了，第三个第五应该会啊，第五超第三，然后是三，我找不到标，找不到标，我打把数怎么说？这就是这样找跟大。不要我懂，那时候找不到标。我念哪个？啊，这个。八点。为什么？我好，我是等一下那个，我给。可以，不要讲了，这样不要听到，我这边有人，然后他有凌晨12点的，第二点的。这里他这个那个是俺的标志，我我要靠你讲，我晚上我就也是必须。然后就是给他逼一点，然后因为你到今年这种到7点。
怎么怎么开？哎，可以跟他们一起上课啊。
比你们还快啊！
还没有教哦，可能
有自觉的还有哦。
超度你是在这种的所谓，我是不想超度啊，你好像是。他想要去拿公立拿，然后 fail 了，然后继续做 engineering。
那你怎么不要直接去做 engineering 就好了？
啊，对，我在读啊，对吧？那真是。理解方面。OK。对啊，还有不要这个 analyst 的高两个人。
OK，
大学太少，连给你读啊。
他要读什么样的 analysis？
等下当完愿望写生，你发现我讨厌我搞啥，这个在哪边？
可以去啃那个 Rudin 呢？Rudin 来啃。
哦，他有笔记我讲过，他有笔记。反正我不要讲那个 OK， 我就去拿。
所以你是基隆的哪里？对啊，对啊，你在哪一间大学中学？啊，就一间嘛那个。哦，就一间嘛。像你几岁？啊，你零几年
19。
你们呢？05，这样应该认识吧？还差一年吧？要问金盛呢？你是阿赛还是三赛？你是三赛。他们有一个同学是阿赛。啊，你会认识吗？阿赛的人比你大一点，阿赛。不是阿赛，是那个商科。你是理科的，你认识商科人吗？你真的是太年大。
我想要用这个啊。
刚开始，刚开始。
Hello. Okay. So you want to continue or you want to ask question or you want to do something related to your course? I mean, anything that you want to ask? Right? Anything you want to ask? You laugh. Later. I mean, continue is the same thing. Yeah. So maybe we can try some real life. Real related problem to yours. But you want to ask or you want to show me the question? What do you mean by anything? Other than this one? Okay, so before that, before we go to anything, okay, before we open to anything, anyone still want to ask about this epsilon delta stuff? Or when you read through the handout, which part you don't understand? Anything you want to ask about it? I already tell you the basic idea, okay? But maybe different question have different technique. I think this handout is quite complete in the sense that the majority of the techniques that we use in the question here should be around this type. Yeah. Okay. You understand what I say? Okay. Anyone still want to continue on this part here? No? If not, we can go into your problem. Your problem.
What kind of anything? Not max one, not max, not max. Which area? Continuity, infinitely differentiable. Okay. Okay, sure. So what do you want to know about that? Very easy. Okay. Question very easy. Question very easy. See first.
我看不懂课本报，
哦，看不懂课本。课本。
呃
What is MA 啊
这个是 Calculus 2
？Calculus 2
的课本，
？Calculus 2有课本咩
自己
？You are looking at MA 1. Okay.
反正这还不如我完全看不懂。
Wow. Okay, this is a bit advanced, oh.
那
Okay. Hey, this is the last part already.
last part 我学
This is last part.
学到这边了。
Oh, okay. So you okay? Sure.
那个课本讲lift as exercise， 然后去做不出来哟。
那里
没有，这个是我另外一本课本讲 lift as exercise， 这本写出来了。
Okay. So you don't understand the solution.
嗯，
Well, okay. You don't understand the concept, or you don't understand the proof.
我懂它 proof by induction， 可是我有
Oh, okay.
啊，
Okay. Oh. 可是什么？
可是我不太懂它的 pattern 哦，不太懂它的 pattern， 为什么它突然有这个东西出来？我不懂为什么它突然有这个。
Okay, maybe let's. Okay. Actually, this question is quite technical. Got other question first or not? Or it's his turn, or if you don't have, then it's his turn. He's asking about. I mean, cannot say it's MA1, but
这个是
it's-
Taylor series 不一定等于它的 function
yeah, sure.
的其中一个 example，
Okay.
然后之后我就 prove 不到
Okay. So you just want to show that it's infinitely differentiable.
啊。
Okay. Well, I think I won't go through the proof yet, but I will tell you the what you need to do.
对，大概讲做就好。
大概讲说好，可以我跟你讲大概，有抄一下题目。对。Okay, so there's a theorem like this. So you look at a specific function here. So this function, what does this function do? So let's define this function. So this function takes x to two things. Okay, so it's piecewise defined. So it's an exponential of 1 minus x squared. Okay, so basically what is this? This is just e to the power 1 over x squared. If x is non-zero, and then 0 if x equals 0. Okay, then you want to show that. So there are two statements here. And then is an infinitely differentiable function. Second, with n equals 0, fn at 0 equals 0 for all n. All right. 对。
这个我大概还有一点思路，这个完全没有。
Okay. Okay. So okay. You
OK，
want to sit down or
sit down， I sit down。
Okay, you sit down.
OK，
Yeah. Okay, so this function here, first of all, why is it piecewise? Why is it piecewise? Sure, piecewise implies different case. So why do we want to make it different case? So what's the case? Okay, good. So 1 over 0, basically 1 over 0 doesn't define. Okay, so
Okay, undefined, good. So at that point, you cannot use the exponential to get the value. So you need to manually define it. Okay, so you manually define, you just take it to be 0. Okay, take it to be 0. Okay, good. Can anyone sketch this graph or not? Can sketch this graph? Oh, you use that side. See if I can do it manually or not. Okay. So let's try. Let's plot y equals to 1 minus x squared first. What's 1 minus x squared? Anyone know how to plot it? Where does it come from? It come from x squared first. Okay. So basically, x squared, you will have something like this, right? X squared. Okay. And then 1 over x squared, you should split like this, right? 1 over x squared. But if it's minus, then go to the other side. Okay. So what can you see here? One point disappear. The point where x squared equals 0 disappear. Cannot 1 over 0. Okay, then the point around 0, 1 over like 0 0.1, 0 0.00000001, you get a very large number. Okay, so should to infinity. And if you take exponential of these values, what do you get actually? E to the negative large number. E to the negative large number. So you see, okay, what's okay, wait. So let's go to the basic graph of E first. Y equals to EX, how to plot? No, right? Positive, very good. Positive. Increasing. Can I do or not? Okay, what? Sorry, I'll be clear a bit. Okay, maybe I use the other color. Can go here or not? Why not? Y cannot be 0. X can be 0. E0 is what? E0 is this point here, 1. Can. What is E to a 0? E to a 0 is E, who say? 1, right? Huh? No. I'm asking about EX here. E to the 0. Yeah, 1, right? Okay. So what's wrong with this graph here? Y cannot be 0. So this graph actually is asymptotic to y equals 0. Okay, so you get very close to y equals 0, but you never meet it. Why? Why is it true? On the left-hand side, what's the value you get here? E to the negative of some very large number. What is this? E to the 1 over, let's say, a million, 1,000, 10,000, yeah, for example. Let's say. How many 0? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, good. Okay, so if you apply that concept to this minus 1 over x squared here, what do you get? What do you get? What do you get? Okay, so you get this graph actually decreasing towards the origin. But like what we said just now, right, it gets asymptotic to 0. So this decreasing on both sides here is closing to 0. So that's why, how do you define this point 0 here? You put it at 0. Supposing that they meet. Supposingly they meet. Okay. So just now we learned the idea of limit, right? So from both sides it approach to 0. Then we put the limit at 0 there, put it in, so that it is continuous, like what the front classmate here saying. Make sense, huh? Good. Makes sense. Good. Okay, very good. Okay. Well, now you need to come in with a differentiability. What's the definition of differentiability here? Okay, sorry. Let me laugh. Okay. Well, okay. Right. So differentiability also look at the concept of limit. What kind of limit you are taking here for differentiability? Okay, always when we want to ask this type of question, differentiable, continuity, then you need to recall what's the definition. Okay, so I will say that function f is, let's say, differentiable at the point x equals to p if what? If the following limit exists. Okay, so what's the limit here? We no longer look at fx anymore. What we look at is fx minus fp over x minus p. The limit of this guy exists. Hey, what's this? Difference of y divided by difference of x. What's this? Slope. Okay, very good. How to draw this slope here? Oh, you want to show differentiable? Is it differentiable everywhere? Your point, differentiable everywhere. The question there got fixing any point of differentiable everywhere. I guess it's everywhere from this graph here. So let's pick one particular point here. Let's pick our p to be 0 here. Okay, so what's the slope we are talking about here? Fx minus f0 over x minus 0. Okay, so the nearby x, where is the nearby x here? Let's say the nearby x here is here. Okay, yeah, let's draw it further. Let's draw it further. So here. Okay, so it's the difference. Okay, it's the difference between, let's say this point is fx, and then this point is fp here. So f0 in this case. Okay, so you are taking the quotient between fx minus f0 and x minus 0 here. So this part is fx 0 over x minus 0. Okay, but you notice that this quotient here actually is a slope. Just now say slope, slope of some linear graph. What's the linear graph we're looking at here? So I claim that there's a graph with this slope here. Fx minus f0 over x minus 0. There's a graph. So meaning there's a line y equals to mx plus something else. There's a line. Just now your friend says that if you want to find a linear graph, what do you need to do? Find 2 points. So what's the 2 points here? The 2 points here is actually this fx here. Okay, this here is x fx. The other one is exactly 0 f0. So you're actually looking at the slope of this linear line here. So let me use that. Okay, so you are looking at this slope here. Then what does it mean by limit of this slope? Meaning what? When you take closer x, right? When you take closer x to this 0, right? What can you see? Can you see that what happened to this slope here? Getting flatter, Getting flatter. Flat until what? A horizontal line. What's the gradient of horizontal line? 0. Okay? So that's why you got a 0 here. Why? Why this says that this is 0? So we haven't defined, right? If this limit exists, what do we call it? then this is exactly f prime p. If it exists, then we will call it this is f prime p. So f prime p is actually computing this limit here. It's not the power bring down -1 like that. 10 -1. That formula is the result of this limit. Okay or not? Yeah. Okay. Yeah. Question? Yeah. Then you continue. How continue? Well, I mean, okay. So okay, how to continue? So you can see here, this f prime p, right? Just define for one p. Obviously, you can look at all the x's. Then you will have all the limits. How do you build a function? I ask you, how do you build a function? How do you build a function? X equal to x. That's one of the function. Y equal to x. Y equal to x. Okay, that's one of the function. So yeah, again, y equal to fx actually is more important. So what does it mean by y equal to fx? I give you an x, you give me a y. So this is just one x, p. You can try different p. Then you will form f prime x. Okay. Then f prime become a function. Then you inductively, recursively play the game with f prime p, f prime x. Then you define what is f prime prime x. You understand or does it make sense? Okay, let me write more. So if f is differentiable at x in the domain, and let's say this function is from R to R, differentiable at x R, then what? Then f prime from R to R exists. Okay, so what does it mean here? What's this function doing? I give you one x, you tell me this limit here. Okay, so let's use another fy. Doesn't matter actually because we put the absolute already. This is a function, perfectly good function. So you ask whether this f prime differentiable or not. Do again. Play the same game. So that's why you have induction here. You need to prove it for every n. So whenever why do you have induction? When do you want to prove by induction? And uncountable. So basically there are different infinity here. But this induction is to prove a statement that is true for On. Prove the statement that's true for On here. N here need to live in where? Not real number. Real number you cannot induct, These are just natural number. Okay, so you have to prove the base case. Okay, depends on what base case you have. Your base case to start with 1 or 0. Okay, start with base case. P1 is true. Then assume Pn is true, prove that Pn plus 1 is true. Because why? If you prove that Pn implies Pn plus 1, meaning what? P1 will implies P2, P2 will implies P3, then you will get all the way for all. And that makes sense. Okay, so induction holds here. And then infinitely differentiable, then you need to do the definition I told you, basically. Maybe when you do 1 second time, third time, fourth time, you'll see the general pattern, and then you can use the pattern to summarize all the method. Okay, basically, there's one way to look at this problem here. So, well, you see, just like I told you that if you want to show that it's differentiable, right? Meaning what? You need to show that the limit exists. But if it is infinitely differentiable, you need to keep doing the limit of the secant, each level. Okay. So, well, do you know that exponential is infinitely differentiable? You know, huh? Okay, if you know that, then basically for x not equal to 0, it's already infinitely differentiable. Then you just left with one point to show, which is the point 0. And then this question here doesn't just prove that it is differentiable, the limit exists. It tells you what's the limit. It's 0. You understand or not? You don't understand? Again. Okay, again. So, what this means? Okay, so let me write down this. On the definition, okay, it must be very clear inside your mind what's the definition here. So, what's this definition here? Limit of x going to 0 of f of n minus 1 n minus 1 x minus f minus 1 0 over x minus 0 absolute value. And then it tells you that actually this limit is 0. You need to prove it. Yeah.
Assume this is true and this induction.
You cannot, what do you mean assume? You need to start with base case first. What's the base case? No lah. N greater equal to 0, right? Yeah. I didn't copy wrong, right? Is there a strict equality there or is it strict? Yeah, so you need to start there. Makes sense, ma, right? Correct, lo? Correct, lo? So it makes sure that your base case is true. Ah. It's actually yeah lah. That's why lah. So it gives you something is true so that you can start, ma. Otherwise, how to start? Correct or not? You can show. Actually, in real life, you should try. Compute F1 first. Compute F2 first. Compute F3 first. See if you have a general pattern or not. For you to deduce the inductive step. In general, you need to do it. I mean, yeah, I mean, yeah. Yes. Once you see the pattern, then you can try and generalize to n plus 1. Okay. Okay. Yeah. Okay. Good. Thank you. Good. Yeah. 想想看。Where do you get the notes from? Website, huh? Good. Okay, good. Huh? Okay. Oh, so why? Because of probability, Also, you bring calculus question to her. You mean in what course? You are under her course or what? Oh. Okay. I see. So why are you looking at this function here? Oh, you want to prove it? Interesting. Good. You cannot prove it. I see. Good. Okay. Any other question? I thought someone say you guys want to know about epsilon and stuff. What's that thing? What's that?
谁来的
Overload 啊？
哇哦，
And finish already. Okay.
Like depends on you. And then I think they pay for us. No, they prefer one to one. I think.
The people one. Oh, okay. Okay, can. Oh, 2个钟。Okay. Then thank you. Thank you very much. I hope you guys can do well in your study.
Right. So yeah, Epsilon Delta weeks the whole week，所以你们可以这 yeah